Hello, and welcome back to another video. In this one, we're going to be wrapping up the Go CLI expense tracker application that we've been working on for the past couple videos. And to do so, we need to implement the list command for our CLI tool. So just like how we can go into the terminal and type ls to list all of the directories and subdirectories files within our current directory, we want to be able to list out all of the expenses in our expenses.csv. Therefore, we need to create a new function or command with the cobra-cli. So returning back to our terminal, we'll do cobra-cli add, and then the name of the function that you would like to add, which I will call it just list. Hit enter, and it tells you where it was created. And also very similar, we get the list.go file, and in here, we're given the short and long description and how it's used. We can confirm that it works with go run period list, and we get list called. To maintain a similar pattern of when we did the add.go, we'll go and create a utility called expense-lister.go. So expense-lister.go. And in here, this is where we're going to call a function to list out all of our expenses. So it will be in the package utilities, and we're going to have several import statements, but for now, we'll just start off with fmt and then have a function called list expenses that takes in no arguments, and we'll just do a quick print line statement that says list expenses called. We'll save this and then go back to list.go and insert that call. So we just have to say utilities.list expenses, save, go back down to our terminal, run the list function one more time, and we get list expenses called. So we know we're in the clear for wiring everything up. The first thing we need to do when we want to go list the expenses is first access the file that contains all of those expenses. So we no longer need this print statement, and instead we need to first open up the file. So we'll do just like we did over in the expense-adder.go. We'll say file error is going to be equal to os.open file, pass in the file path, so data expenses.csv, then the methods in which that we're going to just open it, so os.o underscore, and we're just going to be reading this file. We're not going to do anything else to it. Then the file permissions. We also need to check if the error is not nil. So if it is, we'll go ahead and print out an f error f. We'll do a format to f print f out to the standard error by saying error opening file. And we'll go back here and make that all lowercase and do an early return. Else, now we have our file, so we can create that CSV reader again, just like how we did in the expense adder. So CSV reader is going to be equal to csv.newReader given the file name, or just the file object reference that we have. And with this, we want all of the records in here because we're going to print them out to the screen. So records error are going to be equal to csvreader.readAll. Again, let's check that error. So if error is not nil, we'll do a format.fprintf out to standard error again, saying error reading file. And now that we have all of our records, let's do a quick print line of all of the records out to the terminal. So run the list function and we get an error opening the file. And I see what I did here. I accidentally named it incorrectly. So we go and run this again and we get that 2D array sent back to us. We've basically covered all of this stuff in previous videos up to this point, but now we're going to try to write out these records in a tabular format to the console. And to do so, we need to use the tab writer package from Go. So instead of printing these records, we're instead going to create a new tab writer. So I will call it tab writer, which will be instantiated to the tab writer package.newWriter. And we need to pass in several arguments to this new writer function. Now the first is where are we going to write to, and it's going to be os.standardout, so just to the console. Next, it takes in a min width. I'm just going to give 0, and for tab width I will also give 0, and lastly for padding I will give a 2. When we do use padding, I want to use a space, and then lastly there's some flags that we can set. And so I just want to use tab indent. So I will just say tabwriter.tab indent. And we can use this tab writer to then format everything in a nice, beautiful format to go out to the console. Our next step is that we need to iterate through all of the records that we got back after reading the file. So we'll do one of those for each loops, or for the for index value loop. So for index and value, or we'll actually just call it a record, in the range of records that we got back, we have two conditions. Because when we iterate through all of those records, the very first record that we go over is actually the header. So we'll say if index is equal to 0, I want to print out the header. So I would do a format.f print line, give it the tab writer, which is our writer to write out to the console, and then what we specifically want to write. So it would just be ID, and then a \t to signify that we're going to have a tab spacing here, the amount, then another tab, the source tab, and then lastly the timestamp. So we'll just say, we'll call it added, and that's only if the index is 0. And then once we're done with that, we'll just do a continue statement and exit out of that a little bit early. If we're not on the very first line of this CSV file, then that means that we're actually reading in a record for an expense. So let's go ahead and parse out each of the pieces of the expense file. So first we have an ID, right? So ID is going to be equal to the record at the very first position. If we go look at our expenses CSV, the source is the next spot. So I think I have it wrong. So I think I have it wrong up here. Yeah, I have source and amount switch. So let's just swap those. So source and then amount. So then down here, we will have source will be equal to record in the second position. Now the amount will be a little tricky because we stored it as an integer. So we'll need to divide it by 100 to get its decimal value, and then also place a $sign in front of it, and we'll get there. So we'll do that in a series of steps. So first we'll say amount in cents will be equal to the record at spot 2. And I'm going to modify this actually to amount in cents stir to signify that this is a string. What we want to do next is now convert it over into an integer. We'll say amount in cents, and that will be equal to the string conversion package a to I, and that will be equal to the string conversion package dot a to I, which gives us an int and an error back. So we pass in the amount in cents string, and I'm going to ignore that error that it gives back because we're the only ones writing to this file. So I trust that we're only ever putting in integers into that spot. So instead of having the error, we can just use an underscore. Now that we have the amount in cents, we want to convert it over to the dollar amount. So have that % sign in there. Amount in dollars, and that will be equal to the float conversion of the amount in cents, because currently amount in cents is just an integer, so we have to convert it over to a float, then divide that by 100, and I'll use the decimal form of it too, just to make it clear that we want a decimal value back. But we're not quite done yet, because when I want this printed out to the screen, I want a $sign to be placed in front of the amount in dollars. And also the amount in dollars, when it gets printed out, will have extraneous zeros or other decimal places past 2. So we also want to format that. So lastly, for our amount conversion, we will have amount in dollars stir, and that is going to be equal to the format.sprintf, and I'll do $.2f. And since we're using a formatted string, we can just give the amount in dollars. And then now we finally have our converted amount. We have one more thing that we need to get from the record, and that's the timestamp. That's going to be simple. We'll say created at stir will be equal to record at position 3, or technically the 4th spot. So now that we have all of our variables lined up, we can print them out. So we'll do an format.f printf, and I'm going to do this on a bunch of different new lines here to make it simpler. So we have to first pass in our writer, so that is going to be the tab writer that we created earlier. And then next is our format string, and so that just needs to follow the format of our header that we had above. So I'll have a %v for the ID, again another %v for the source, %v for amount, and then lastly a %v for that added timestamp. So you should have 4% V's and 3 abs. And then at the end of this, we'll want a new line to be printed. And now we need to provide the values for each of our %V's that we have here. So it will be ID, source, amount in dollars string, then that created at stir. And then we need to end it with the parenthesis because of how the Go compiler works. But that's not good enough because we still need to flush the buffer when we go to write this. So we need to call tabwriter.flush to make sure that that gets printed out to the console. So let's go ahead and open up the terminal and run this. But first, let's look at our expenses.csv. So what we'll see is we'll have the ID and the header basically printed out to us, but it's not going to be in this format. We made our own format get printed out here with capitalization and a change of the header names. But then we should see 0, and then we'll get $1,234 for job 1 with the specific timestamp. So let's go ahead and run this. And there we go in a better tabular format. We still have an issue here, but we can see that we get the tabular format printed out to us, but we have two issues. The source and the amount are actually mistakenly messed up. So let's go first take a look at how the source is not getting printed out correctly. So source gets assigned to the second position. So 1, 2, 3, 4. Oh, whoops. I see that I switched this. So I have source and amount swapped in here too. So let's fix that. So source is in index 1. So let's make sure that we have that over in our lister. So source is at record 1, and then 2 will be in that third position. So we just need to delete from here. So it'll be job 1, and then 1, 2, 3, 4, and we'll just leave it there to keep it more simple. And that means I probably have a bug over the expense adder.go. So let's go take a look at that. So again, it should be ID source amount. And when I go to write, it looks like I do ID and then amount and cents, then source. So I do have a bug in my previous video. I'm sorry about that. So pass in the source right there. So let's do just a quick sanity check that when I go to add something, so we can do a go run period, and then it's add with a source of job. Let's go with job 2, and then amount will be 9876. Hit enter. Should have gotten a success there, and so we get 1, which is the ID that matches. Source matches the job 2. The amount matches there, and then we get that created at timestamp. Okay, there we go. Fixed a couple things there. Next, let's look at that float that was not converted correctly. So here, I just simply forgot to do the %.2f. So add in the %, and we should be good to go here. So if I do a go run period list, we'll get ID source amount and added, then the ID, the amount that gets printed out, and then that added timestamp. So we're looking good here. Next, we want to fix this timestamp. Now here's what I mean by I want to improve how this time is printed out to the screen. Someone created a time diff package here where we can pass in a time and then add or whatever we want to do with it. And when we go to print it out with the time diff package, it will say a few seconds ago, or 3 minutes ago, a day ago, or it was within a day. So we get better formatting in terms of we get to know the relative time that the entry or the CSV record was entered versus some timestamp that a human has to parse through the month, day, and year, and then that time zone and everything. So it's better if we can just give a relative time. So back in the code, let's go ahead and use that documentation and create a better timestamp. So right here, I have the create at string. And since it's a string, we need to convert it over to a timestamp that we have over in Go. So I will have the created at TS for timestamp, and that's going to be equal to time.parse. And we can give 2 arguments into this. So the layout string that we need, and since we originally wrote this to the expenses CSV, we use time.rfc3339. We just pass that in, and then the value, or basically what we're trying to parse here. So it'd be the create at string. And this does give us back both a time and an error, but I'm going to ignore that error for brevity's sake. So just pass in the underscore. And then now we want the string value using the time diff. So we'll then just reassign the create@string. So we'll say create@stir will be equal to the time diff package, which we don't have yet. So we first need to import that, which all we need to do is just copy the URL up top, then do a go get statement to get the time diff package, which we don't need the HTTPS. So just delete that, hit enter, then you can download it. And now you should have that time diff package. So now using autocomplete, we can just call timediff.timediff uppercase and then pass in the time that we're looking to parse here. So create@timestamp, and that's it. So we'll go ahead and save. Let's rerun our program here. So when I do a go run list, now we get it was added an hour ago or 8 minutes ago. And now this is better for the user experience. Now there is some formatting going on here. You can mess around with all the tabs and the spaces and the padding up in the tab writer to get it more of a tabular format that you might prefer. But at the end of the day, this is a good start for writing out our output in a tabular format. And that's it for the video. So what we covered in this one was listing out our CSV, fixing a couple bugs, and then also including that time diff package so that we can have relative times. Now in the next video, I will cover how to export this program as a binary so you don't have to keep on typing go run period or wherever your main.go is, and also improve the user experience by making sure that the expenses CSV is always created, whether it's a new installation of the Go tool we create here or if it's been continuously used already. If you made it this far in the video, thank you for watching. Please consider leaving a like and subscribing, and I'll see you in the next one.